Welcome, welcome. Thank you for joining the RADWIN Fixed Wireless Access Solutions for WISPs webinar that WinCom is hosting for us. We're very happy to have you here. We have quite a few folks that'll be joining, so I'm just going to give it a minute or two and then we'll get started. So hang in there with me. We'll start soon. Thanks for joining. We'll get started with the webinar soon. All right, once again, thank you so much. Chuck Bolvin and I are very pleased to have you join the session that WinCom is hosting today. We want to share a lot of great information with you. I'm going to do a little bit of housekeeping while we're waiting for some folks to join. For any questions, you can either utilize the questions box, which I will be monitoring, and or the chat box. I do prefer the questions box only because then I can try and answer you kind of in line there, but either is available to you and I'll be watching for that. And then as far as any issues with audio or anything like that, please do let me know in the chat box so that Chuck and I can try and resolve that. So with that, I know we're 2 minutes after the hour, so I'm going to go ahead and get started. So welcome to everyone who's joined. This is the RADWIN Fixed Wireless Access Solutions webinar for WISPs. And you'll see that we'll go through many of the use cases that are important to internet service providers. Obviously, they will apply to other types of customers as well, but we thought we would give some unique information here that's a little bit focused. Our presenter today, I'm sorry, I'll introduce myself first. My name is Sheila Curry. I'm the Channel Sales Director for North America here at RADWIN. And I'll be just the color commentary, I guess, on the webinar today. But our presenter is Chuck Bolvin, and he's our pre-sales manager for North America. He recently joined our team, and I want to open this up for him to get started and thank him for all his work to get this pulled together. So with that, Chuck, it's the Chuck Bolvin show.
Thank you, Sheila. What an intro. Love it. Hey, thanks everybody. I'm Chuck Bolvin. Like Sheila said, I'm the pre-sales manager here for RADWIN in North America. And yep, I'm a bit new. I'm new to RADWIN, but I'm not new to the wireless industry. I've been doing this kind of stuff for about 25 years. So got my start when the WISP industry got its start, and then did a few other things in wireless and Wi-Fi, and then now I'm back to where I came from again. So I appreciate everybody attending. And I tell you what, let's just get started. RADWIN, for our agenda, we're going to have a rough agenda. We're going to do a little intro, talk about some use cases. We're going to look at the portfolio, the point to multi-point portfolio, a little bit about why would you look at RADWIN, and then some other sample use cases. So let's get started. All right, so RADWIN's been around for, well over 25 years, all right? And we have several strategic and important markets that we play in. Obviously, one of the largest is the wireless internet service provider market, and that could be either through private WISPs or, for example, we see telcos that will do their own ISP networks, and we will see power and electric telcos also providing that kind of service. We do strategic industries such as mining, electric distribution, water distribution, ports, for example, those kinds of strategic industries. And we also do a lot in transportation, primarily with trains, where we do internet or internet connectivity or wireless connectivity between rail cars and between the rail cars, passenger cars, and the siding to provide internet services for passengers. Pretty neat stuff. So we have obviously a very large global reach, 16 offices worldwide, well over 1.3, 1.5 million radios installed, over 170 countries, and over 175 plus customers in North America, and that contains both US as well as Canada. And we are big on carrier grade. That's what kind of sets us apart. This is the kind of stuff that you will see tier 1 carriers use. So this is not the kind of stuff that you, for example, would buy off of eBay or Amazon or anything like that. This is the good stuff. Just a little sampling of some of the partners that we use. These are primarily ones here in the North America, US and Canada. Couple at the bottom, Butler Electric Cooperative and Valley Electric Association. These are both power companies, utilities that also will provide internet service to their customers. All right, so let's go. So when you look at a wireless ISP, all right, I got my start in this business back when wireless ISPs got their start. So right from the very beginning. And one of the things that I noticed was things that were important to a wireless ISP who's just starting. Okay, number one is budget, right? They have a lot of uncertainty when they start out. Are they going to be able to get customers? Are they going to be able to get sites to put their radios? Are they going to have stability? Do they get the right, equipment? So there's a lot of uncertainty, and a lot of that again revolves around budget. These guys work on a very slim margin because they're just starting out. But when you get into the more established service providers, because they're established, their big concerns tend to be, how do I grow my customer base? All right, I need to make my market share bigger. That comes into play with maintaining and controlling your operational expenditures, right? As you grow your base, you can't let your expenses get out of whack, or what ends up happening is you start losing market share, you start losing margin, you start losing money. So that's very important. When it comes to things like deployment, if you're a new service provider, a lot of times you're in a greenfield environment. You're coming in where there isn't any internet service at all. So you get that area to yourself. You have to be able to target the customer segment. You need to tailor to where you think you have the best opportunity. Could it be just a small geography, a small town? Could it be multiple towns? Could it be, I'm going to cover things like small businesses? So you have to be able to, have a strategy. For larger service providers, now you're getting into the point where I'm going to start to diversify. Am I going to stick with just rural, or am I going to start doing metropolitan kind of coverages? Might be towns, suburbs, certain scenarios like that. You're expanding your geography. You're covering a bigger footprint as well. The customer types. Am I going to be serving primarily residential or business, or am I going to be expanding into both? And then obviously you're going to run into increased competition. Main factors, again, new service providers, everything comes down to cost. The cheaper and it tends to be the cheaper the better. Staffing. Is the small service provider going to have the people they need in order to grow that business? They need people to take orders, people to go out and do the installs, people to provide support, for example. And then how do I get support for the products I'm buying? If I'm having a problem with a product that I'm buying from a manufacturer and I have issues, who do I call? Who do I contact? Where do I get my help, and how do I get it? In established service providers, it comes down to scalability a lot of times. I need to limit the need to upgrade hardware. All right, if I've got a particular product that has a limited amount of, let's say, subscriber units that I can add to it, that means I have to be careful of not overloading it, or I have to go up, pull that down, add a new product in there, or add another one. So what's the scalability that I have to deal with? I need to make sure that I have management and deployment tools to make it easier, right? I need, what tools do I need to give to my crews, right? So when they go out and they're doing an install, it needs to be efficient and robust so that they can get their job done quickly, move on to the next site. The types of customers, are they good quality customers, for example? Residential versus small and large businesses, right? I'm not saying that they're when I mean variety, I mean it's the quality of that type of customer. For example, small businesses may not have the same opportunities as a larger business, for example, when it comes to revenue. So you have to see where that plays. Optimizing your total cost of operations with service, right? So service is a big thing. Can I afford truck rolls? How many truck rolls am I going to need? So I have to balance that out. And then how do I make sure that the customers see the best possible experience? As I'm growing my network, as I'm establishing a larger footprint and bringing in more customers, I have to be able to maintain that really top-notch quality of customer experience for the customers. All right, so deployment use cases. All right, we see a mix in the customers that the partners that we work with. We see cases where, for example, the rural telcos and the rural power companies, a lot of that has a relatively modest demand for capacity. You may not see a small town needing gigabit connections to the desktop, to the homes. You have a fewer customers over a long distance or a short distance, but again, the population density tends to be less. Base station cost could come into play because you're now having to cover a wider potential area. When you get into both mixed metro and suburban populations, now the demand goes up. I need capacity. I might be looking at 500 meg, 750 meg type of services that they need, and it needs to be reliable. We can't have consistent drops. We can't have poor performance. When you see what happens nowadays with social media and streaming video, it's got to be reliable. Your customer base is going to go up. You're going to see lots of customers coming in. That also brings in play, do I have enough clean, uncongested spectrum? More times you get into these metropolitan areas, and I see that where I live here, I'm out in the western suburbs of Chicago, in an area that's, you go much farther than where I am now, you get to be more rural. But even though that's rural, in that area, trying to find free, clean 5 gigahertz channels is a real challenge. So how do I mitigate interference and be able to use those channels based on the fact that I may not have as much of those as I would like? So here's some challenges that we've run into, and some of this I've seen. I've done some work with Ubiquiti in the past. And they are a good company. I'm not going to say anything bad about them. They are a good company. They make some great products. But here's some things that we see. For example, when it comes to crowded towers, right? There's a tower system that I helped work on that's not far from me, and the ISP is just a ton load of access points up on the top of the tower. So that kind of means as I'm adding subscriber units, I'm starting to have to add more APs on the tower. So the towers start getting crowded. What ends up happening when I get a lot of access points up there, that means I'm paying more for that tower space, right? That also creates a potential with interference mitigation. We're going to talk about this a little later, but what you see is in the Ubiquiti side, a lot of times they have, in order to mitigate interference, they require going to a more narrower antenna. All right, so we're going to see how RADWIN kind of takes care of that. Scalability as well, part of that is coming from a lack of beamforming, and we're going to talk a little bit about beamforming and why it sets RADWIN apart. And then professional services. RADWIN, we have a very distinct differentiator there when it comes to professional services. Quality challenges. As your user count goes up, your subscriber user goes up, you have potentials with inconsistent capacity. Data rates start to change. Things like interference and jitter start to pop up, and that creates problems for things like time-sensitive applications. Everybody's living on Teams and Zoom now, right? You've got voice over IP, you've got streaming services. They hate jitter, and they hate that kind of latency issues, and which we show we can handle within the RADWIN product line. All right, needs of service providers. What are the three things that they really want most? Consistent link reliability. They want happy customers. They want customers to have the best possible user experience. Number two, they want to be able to handle the capacity, all right? Speed as well as user density. How many APs and how many subscribers can I get on my system? And then number three, cost. I've got to be able to do it where I at least have the ability to make some money off of it. I've got to have that revenue. So here we go. When we're looking at two particular types of product lines within RADWIN, we have what we call our extreme high speed, which is the TeraWin product. That is a 60 gigahertz product. That is of extremely short distance, but it's extremely high speed. We're talking gigabit to each one of the subscribers, but it is a very short distance. We're talking maybe 3/4 of a mile, all right? But very, very high speed. For most of the ISPs that we deal with, the most popular product, again, is going to be in that sub 6 gigahertz platform. That's the 5.8, 5.4, 5.2, 5.7, 5.8 in the point to multi-point range. And from that product line, we can do anywhere from 1.5 to 3 gigabits per second per access point, right? So again, we have the ability to take those higher data rates. All right, so no matter what your network needs are, there is a RADWIN product that we can use to match it. So we have a multiple solutions when it comes to the point to multi-point. The top of the line serves as what we call the jet. The jet access point has a built-in beamforming antenna, and this beamforming antenna can put out individual 8-degree patterns to each individual subscriber. So as each individual subscriber is talking to the access point responds with a very tight, narrow, focused 8-degree beam, right? The Neo, it does the beamforming as well. It's basically a mid-range product. It does the beamforming, but it's on a much wider basis. So little less expensive, little lower performance compared to the jet, but also very cost effective. And then we have something called the MultiSector. This is kind of interesting because if you see that panel, that looks like a folded panel. That's actually two 90-degree panels built into the same enclosure. Now we do that as an integrated as well as an external. So one radio or one unit can talk to at least to handle a 180-degree arc to separate carriers. So here's another comparison. If you look, example, for metro areas for high density, you've got the Neo or the Jet, right? Residential services, for example, that service level tends to be what we call best effort, right? We will try to get the best possible bandwidth to each one of those customers, but it's going to be on a contention basis, right? If we have relatively low demand from the subscriber units, then each one of those subscribers will get a fairly decent chunk of the bandwidth. But as the demand goes up, let's say if they want to get 100 meg, they may not get it. They may only get 50 because someone else is using that bandwidth. If you flip over to a CIR, or a service level agreement type of environment, when you see with the Jet, we actually create within the Jet and the subscriber what we call a CIR. So it's not best effort anymore. This is where we're guaranteeing, if you say I'm going to let this subscriber get 50 megabits per second, they're going to get 50. All right, they're not going to let any other device or any other user take up so much bandwidth that it's going to take away from the individual subscribers. So you can actually create a service level agreement for a particular service, service bandwidth. The NEO, again, is best effort. So if we go back into more of the suburbs, all right, so, and when I see the duo here, when you look at the top, when we talk about the duo and the jet duo, that's actually what we call a dual carrier. There's actually two radios, and we have the ability between those two radios of 750 megabits a second on each one for a total of 1.5 gigabits. We have the ability on the duo to say, for example, if we're doing 5.4 and 5.8, if we have subscribers that are in 5.4, and let's say 5.4 has a problem with radar, because 5.4 is a dynamic frequency control band. So you have the possibility of being interfered with radar. So what will happen is the SU, the subscriber, and the AP will switch those subscribers over to the 5.8 side. All right, so they don't lose their capability. Now, once that interference gets mitigated or goes away, they'll flip back over again. A lot of times they won't even know they flipped. So you've got that dual carrier capability. Put two of those together on a tower and you've got 1.5 gigabits of total capacity. When you're in a less populated area, again, you may not need to have two, so you're looking at about 750 megabits per access point. And we can do 64 subscribers on the NEO and the Jet Pro, but when you do the dual, the system, we're up to 128 subscribers. For purely rural, we have the ability to use the multi-sector. It doesn't do the beamforming. It doesn't necessarily need to, but we have the ability there with the beamforming, with the integrated, to have that full 180 pattern, which is basically 2 90-degree sectors. Makes it very nice, very clean installation. If you want to make it a full 360, you can add another panel antenna behind it. Now you've got a 360-degree capability with a total of 3 megabits per second and 256 subscribers. Now you're in a place where you've got a very nice, small, tight installation. Takes up very little room on the tower. The two main subscriber units we see are what we call the SU Air and the SU Pro. The SU Pro is what would be matched with the Jet, because these are the ones that are going to support CIR or best. They can do best effort as well, but normally we see those in CIR scenarios. And then you have both an integrated as well as a connectorized unit. So if you have a case where you have a very special location where you need a much higher gain, maybe with a parabolic antenna or something, then you can use this. You can use the connectorized. These are compatible with all the variable base station systems. So SU Air, that's the best effort version. Again, it will talk to either one of the base stations, but this one does not do CR. It's best effort only. So as a result, it's also going to be a bit less expensive. This is a little bit about the beamforming. The thing about the beamforming is it is dynamic. If you have multiple subscriber units, each subscriber unit, when it is communicating with the base station, is going to get its own very tight 8-degree beam. So that's great when it comes to things like mitigating interference. If you've got a wide antenna pattern like you see on the left, like in a passive antenna, what tends to happen if you've got a subscriber unit, let's say down on that bottom left, that's transmitting, and there's, let's say, interference in there somewhere from another station, that entire antenna pattern is going to get affected because all those subscribers are seeing that same wide pattern. Whereas with the beamforming, when we send that narrow 8-degree beam, right, interference on one side, for example, where you see that red zone there, interference there won't affect any of the other subscriber units because it's such a tight beam, and it's dynamic. In the dual carrier, in other words, which would be like, for example, the Jet Duo, since you have two radios in there, you have two sets of those 8-degree beams. So, all right. So again, benefits, things like, up to 20 dB radio interference rejection, right? So you're extending that cell. You're allowing the additional capacity. All right. So also talks about, frequency reuse. This also reduces rental costs on towers, again, because I'm not putting up multiple radios. I'm not putting up large antennas, external antennas. For example, you'll see a lot of cases where you'll have a base station, and then that base station requires external antennas. So now you're mounting multiple items. You've got cables and lightning arresters that all have to be taken into account. But with the integrated system and the beamforming, that's not necessary. So it's a much cleaner scenario. Network benefits. Again, what we talked about, we're saving tower space and tower rental costs. We're getting much better downlink. The reliability is going to be better. If you look at the prime carrier capability, a typical base station, as you see radio events happening, the NEO, for example, is not going to be as impacted as a typical base station. So that could be NEO, that could be the jet, because of the beamforming. So as we see more interference come in on those products, the impact or the degradation is not going to be anywhere as bad as what you see with a system with a traditionally passive antenna. And you can see a little bit there on that that little motion there, that little animation, so you can see what's happening as it's moving around from subscriber unit to subscriber unit. This happens again like that. This dual carrier scenario, or this prime carrier, basically happens primarily when you see cases where you're using, for example, 5.4. 5.4 is a band that can be susceptible depending on where you are. A lot of times it's what they call terminal Doppler weather radar creates this in metropolitan areas. You'll see this. So when the radio detects that there's a radar that is started up, the radio has to move. It has to move off those channels, and a lot of times it's going to move up to, let's say, either the 5.4, or excuse me, the 5.2 or the 5.7 band. Well, because you've got that built into those products, into the Duo system, it will switch these subscribers over automatically, and then once the radar stops or the channel frees up with the interference, all those devices will flip back again. So it's kind of a nice fallback. All right, beamforming is great because you get a stronger signal, you get better interference immunity. So if you look at that little animation, if you see they talk about that dual horn, that's a 60-degree. That could be a horn antenna, it could be a panel antenna. I don't see too much horn antennas, but I see panel antennas a lot, 60-degree or better, sometimes 45-degree. When you have a 60-degree antenna in that orange area, any kind of interference within that area affects the signal, right? You're going to get a signal degradation. But if you use the beamforming, where you can narrow that up, if you notice what happens is less likely to get interfered with, and you see the additional gain. So your subscriber units get less interference and a stronger signal. That's that orange. We also allows it to use fewer radios per tower to handle a full 360 degrees. If you're doing 60-degree directional antenna, that's 6 radios, right? A 30-degree would require 12 radios. For us, it's as low as 4. So, excuse me for a second here. All right, some of the benefits that we derive, and this is some of the differentiators. All right, again, because of the beamforming, and I really play up that capability because it's something that not all manufacturers can support. That's kind of special for us, and that's that beamforming capability. So the service reliability goes up. The connection quality and the user experience becomes much more consistent. We can support higher service packages, sometimes over 100 megabits or more. We've got subscriber units that are capable of doing 500 megabits a second. They will handle anywhere from 100 up to 500 megabits a second. Because of how we handle AP and subscriber synchronization, we can smooth out the connections and make sure that time-sensitive apps like voice over IP and Zoom and Teams and things like that don't suffer from jitter or any kind of latency issues. We even it all out. Again, that's makes the availability of the service better. It also allows us to do base station coverage better because of the beamforming. We're getting that tighter beam, higher gain. We're able to reach out more. We can support both residential best case versus business, CIR kind of arrangements on the same system. We don't need to have two. One of the things that really helps is reduced service calls, right? I'm not going to be getting as many service calls because the system is going to be reliable. The customers are going to have consistent service. That also means I'm not going to be sending truck rolls out every time I get a call. Truck rolls are expensive, right? You've got equipment costs as well as personnel costs. From the commercial side for ISPs, that's revenue growth, all right? You're going to get more customers in there. You're going to have happier customers, and happier customers don't leave and go somewhere else. So your churn rate is going to go down, and you're reducing your expenses as well, because I'm not doing the truck rolls. I'm not doing the service calls. I'm not having to necessarily go out and replace equipment. You have a generally higher performing, higher availability network. The jet is very popular by the larger service providers because they can do this CIR, and that's very important, because now they can provide a guaranteed information rate, and actually they can charge a premium for that instead of best effort. So that's a revenue source. There's the Jet Duo. Now you can't tell the difference, but that's a dual radio system in there. But it's in one enclosure. So that right there's the Neo. Looks very similar. It's very similar to the Jet, except again, it does not do CIR, and its beamforming is different. It's a wider beam width. It's not 8 degrees. It's closer to about 20. So here we go. There's a comparison between both the Jet and the Neo. Both 5 gigahertz, although for Canada, I believe they are also available in 3 gigahertz. In fact, I'm right now looking at a potential project up in Canada for a wireless ISP that looks like they're going to need the 3 gigahertz port to get through some trees. So again, antenna gains are a little different. The Jet's a higher gain antenna than the Neo. Beam width on the Jet 8 degrees versus 20 to 25 degrees for the Neo. But again, they both work pretty much the same. Like I said, the key differences are the Neo is going to be a less expensive alternative, so it's a more moderately priced product. So now we're looking at something called the multi-sector. Now the multi-sector is not beamforming, all right? Each one of those sectors is 90 degrees. It's a fixed 90 degree, but it can be dual carrier. You can have 2 radios. In fact, you have an integrated unit and you have a multi-sector connectorized. So the radios are built in. Each carrier would be on a different sector. So you have a 90-degree sector on carrier 1 and a 90-degree sector on carrier 2 for a full 180. So if you want to do full 360, if you're doing the integrated, you need 2 of the integrated units, and they basically mount back to back. So it makes for a much cleaner installation. So again, to talk about things like costs, you're reducing what you're putting up in the tower, because tower owners charge by how much you put up there. The more devices you put up there, the more expensive it is. And because this is all carrier grade, the odds of having to go up and service it are greatly reduced. All right, so if we look at the multi-sector, if you look at the density comparisons between the multi-sector connectorized and the integrated, if you see the difference on the connectorized, you can do 2 of those panel antennas, or you can do 4 total. You can do 2 per radio. So you put 2 radios in. Each radio is capable of 750 megabits a second. So 2 of those back to back on the same tower gets you 1.5 gigabits of actual throughput supporting 4 antennas. Now, when you get to the integrated, with the connectorized, you have an option of a wider, broad selection of antennas, higher gain antennas, if you need to. But for the integrated, it's a nice, clean, fixed, built-in 90-degree integrated for a total. So 2 of those alone get you full 360. Here's kind of an example of what the radios look. That's an integrated on the right, and I can't tell on the left. I think that's an integrated as well. I have to admit, when I came to RADWIN, that's the first time I'd ever seen that. It's such a neat idea. One of the things that's really important, okay, is how am I going to plan for these devices? How am I going to design? How am I going to deploy them? How am I going to manage them? Because once they're up in the tower, I do not want to be visiting it again, right? So we have tools in play. WinPlan, that's our network planning tool. Through WinPlan, you can, and it's integrated with Google Maps, which is really nice. What happens is you can actually create your scenario, plot the points, tell it the tower heights, the type of radios, the type of clutter data, and it's going to project and predict what your performance is going to be. So you can plan and design the network. Once that's done, you can take that plan, all right, and you can download it to WinDeploy, which you can give to your crews. Now, WinDeploy allows them to provision the devices, the radios, and once they get out on site, they deploy them, they mount them, and with their cell phones, with our package called WinTouch, they can go out to the InSite, to the installers, can take those out to the subscriber sites, mount the subscriber units, and through their phone, do a very simple antenna alignment, and they're up and running. So we automate that as much as possible. These tools are all free, by the way. There is no charge for any of these tools. WinPlan, WinDeploy, WinTouch. And then WinManage is another tool we use, or the customers can use, that allows them to manage any of this equipment, whether it be a radio, a subscriber unit, if you're using any of our other products, let's say like the Smart Node or the IDU systems. These are all manageable through WinManage. And again, this is all free. We don't charge for it. All right, so here's kind of an interesting comparison. All right, now the number of devices, CPEs per AP, obviously people can debate this, but these are based on observations, for example, that I've actually seen over the years that I've used Ubiquiti, and the customers that I've talked to that use it. One of the key things about capacity with RADWIN is this beamforming. All right. Because of the beamforming, we have the capability of putting 100, maybe more, on an AP and having them work reliably with a good user experience. You can shove a lot of devices onto an AP, a lot of subscriber units, and it'll work, but it may not work well. All right, people are not going to be happy. We're going to be able to put more devices, more subscribers on that system and have them work well. So again, that's going to save power, space, and cost because I'm not having to put a lot of different antennas up. Interference mitigation. Again, this is the key thing. This is the secret sauce to the beamforming. All right. Ubiquiti, we tend to have wider antennas. I think their smallest antenna is about 45 degrees. So it goes 45, 45, 60. Now they do have a stacked 30 degree. That's a big antenna. I've seen that antenna. It's huge. So that's a lot of tower space there. So I'm sure it works. I'm not going to say anything bad about it. I'm sure it works. But you know, when we have something like the beamforming where we can do, you know, that and more in a fraction of the size, that says something. We also can do dynamic channel bandwidth. We can dynamically switch between, for example, a 10 or a 20 or a 40 or an 80 megahertz channel dynamically on a per subscriber basis instead of locking the base station into a particular channel bandwidth. Again, tower occupancy. Think of a typical guideline might be for every 4 Ubiquiti radios, it's only going to need 1 RADWIN. Right. Again, it all comes down to tower space and tower costs. TDD synchronization, Ubiquiti does do it. Okay, they do this. They do the synchronization, but we've built something else into our TDD and our synchronization system that allows us to play a bit better. We do things within the radios that mitigate and take care of latency and jitter on a better basis. That works really great when it comes to things like capacity, stability. Again, when you're talking these broad antennas, all right, you know, 45, 60, 90 degree antennas, because of the interference that can come into play, it creates jitter. All right, jitter's the kiss of death for things like video and voice. They don't like jitter. That creates issues and latency. So what we're going to do with the beamforming is, through that, we have a much more consistent user experience. Again, you know, work from home. Not everybody's working from home, but a lot of people still are. But again, that's what's going to help. Durability. Because we are carrier grade and we are used by tier 1 carriers, the ruggedability and the survivability of the radios is going to be better because, like I said, we see AT&Ts and we see Verizons, and they use our equipment. So the carrier grade piece of it is extremely important. Vendor support. It's kind of hard to beat RADWIN's vendor support, especially when it comes to things like professional services and our crews. These guys are the best in the business when it comes to support. Documentation is easy to get. Generating tickets for our help for our TAC is easy to get. Our TAC is available 24 hours a day, 365 days a year. Enough said on that one, I guess. Okay. This is a sample of what the air interface looks like. If you look at that bottom right display, that chart, you see what happens when you start getting a lot of sessions coming in on a competitor system. And what you'll see is that's capacity in bandwidth for each individual user. And you see it kind of tends to get all over the place because there's no management and there's no control over the system itself. Everybody's coming in, their individual jitter might be different, their signal strength might be different for a number of reasons. So what ends up happening is you have a very inconsistent connection, right? Some people are getting 30 meg, others are only getting 5. But what we're doing within the APs, and this is both the Neo as well as the Jet, as we see multiple streams coming in, we're going to start managing those streams and start leveling out the jitter. What we do is we take each frame and each packet and we're breaking it up into much smaller pieces than you would normally see. So because we're transmitting much smaller pieces, the jitter doesn't affect it as much. And if we have to retransmit a small little fragment, it's easier to transmit one than a much larger one. So it allows us to even everything out, make it a much more consistent connection. So if people, instead of flipping between 2 megabits and 30 megabits, everybody's getting a nice, stable 25 megabit per section connection. Right. Some of the customers that we've seen, the use cases, again, rural electric co-ops are big for us, telcos, smaller telcos in the rural WISPs, we're starting to see products like the RADWIN, which is going to be coming out here pretty soon. It's very, very close to general availability, but the product's actually already out being used in controlled introduction right now in at least 3 places, and the performance and the reliability on it is amazing. This is going to be a really neat product when it finally gets fully announced, which is going to be very, very soon. I've seen it now. That on the side there, when you talk about being able to put a lot of devices in, this is one way that we're able to do this. We talk about tower space, and we said how bad it is, but there are cases where you just don't have a choice. We've seen customers use this for things like in the oil industry, where they have or gas wells spread over a wide area. 300, 400, 500, 600 gas wells. These providers will actually use RADWIN to provide the connectivity to all these gas wells. And we do that through this jet technology. Those are NEOs, I think, right there. But again, the capacity's there with the beamforming. Now, these are all low data rate, though. This is the thing is the gas wells don't require much. So it's not like we're doing 150 to 200 meg or 75 meg. These types of gas wells and this type of telemetry only require a megabit or so at top. So that's why we see that. But we can actually do that because everything is GPS synchronized, so they don't they don't clobber each other. Rural telcos, these are just some examples of the rural telcos. Some of these are in US and some of these are in Canada. I couldn't tell you where they are, though. Amarillo Wireless, obviously that one's in Texas. So this is an example using the jet. So they're using that CIR. So business consumers are getting a CIR of 50, businesses are getting 150. High Desert. So we are about to the end, and what I'd like to do is thank everybody. I'm going to show the map for Wincom, who graciously gave us the time to do this today. This is their map, and again, we will figure out a way to get the deck and everything to Wincom for everybody if they want to see it. But this is their coverage map. Very well done. And here we are. This is for us, RADWIN. I'm at down at the bottom left, so I cover all the areas in purple. And that's about it. Sheila, do you want to kind of summarize things for us?
Yeah, definitely. So if you could go back to the Wincom map, please.
Oops.
So I really just wanted to point out that the Wincom team has an offer that RADWIN has extended to them to offer to potential customers, new customers. That's anyone who has not purchased RADWIN in the last 18 months. There's a voucher or I don't know, I'll call it a coupon based on volume. So it's tiered a bit based on the larger the order, the bigger the discount. I thought we had a slide on that in the presentation. It doesn't look like it. We will add it before we get it over to the Wincom team so that they can share that with you. But we definitely have offers to make that can help you save money. Now, I know Chuck pointed out several times the differences between the Jet and the Neo products. Please do keep in mind the Neo products are substantially better costing and are very competitive for the ISP space, to deliver the services that you're trying to deliver. Now, you may be able to use those in certain locations for the services that you're delivering to those specific, let's say, neighborhoods or businesses. And then maybe you might need a Jet Pro system for a specific business customer for those committed information rates. But you definitely want to look into the ability to take the different solutions, including the multi-sector, and really design your network the way it'll be the most advantageous, not only to your cost, but to your customers' needs. So, you know, again, reach out to your WinCom team with questions, and they will make sure that you get help, and they will pull in, Chuck, if you can go to RMAP, then they will pull in the appropriate RADWIN team member to help you, whether that be designing part of the network or, you know, actually talking to a salesperson about a specific BOM of materials and how that can get deployed, et cetera. So I want to thank Chuck for his work on preparing and providing the webinar today, and I want to thank each of you for attending. I do see a question in the chat box. I will make sure to address that. Any and maybe Chuck, I don't know, any plans to add multi-user MIMO to the JET platform? Do you have any information on that, Chuck?
I've not seen anything about. I've never not seen anything about that. But when you think about it, because of the way the beamforming works, we don't need the multi-user MIMO. The beamforming does essentially the same thing, but it does it with much, that's what the tighter beam width does. A lot of things you think with multi-user MIMO is, yes, you can have devices talking at the same time, but their antenna bandwidths, beam widths tend to be a bit broader. So what we're doing is we're trying to get the best of both worlds here, get good performance, good mitigation when it comes to interference and range without having to go to this big, massive MIMO panel.
Understood. So I will make sure to also send some additional information to Camille. I hope I'm pronouncing that accurately. And I'll make sure that you get a little more information on that. With that, I would like just again to thank everybody for being here today, and we'll go ahead and wrap up. I know that WinCom plans to provide the presentation to anyone who attended today. And so you'll be able to utilize that and reference it as much as you need to. So thank you so much and have a great rest of your afternoon.